Boys and girls, here we are with lesson 4.4. This lesson is helping us to determine if lines are parallel to each other or if they are perpendicular to each other based off of their equations. Now you guys all know that parallel means that they're never going to intersect. They're going on forever with never intersecting. That means they must have the same slope. So the big idea here, parallel lines have the same slope. Obviously perpendicular lines are going to have a different slope, but they have a special relationship that we will share with you today. So in example number 1, our job is to write an equation in slope-intercept form for a line that passes through the point 4, -2 and is parallel to this equation. So just like we did in our previous work, we are given an x, a y, and because we know that it's parallel, we know that m has to be the same. So I'm going to use m of a 1/2 like it shows on this equation, and then I'm going to use x is 4 and y is -2. So I plug those numbers into my slope-intercept form, which is y equals mx plus b. And then all I have to do, folks, hold on, I gotta dismiss this. All I have to do then, folks, is to plug the numbers in. So y was -2, m is 1/2, x is a -2, and we're going to figure out what b is. 1/2 of a -2 is a -1, and that's going to be equal to that -2, and we have that plus b over here still. And to get b by itself, we then have to get rid of a -1. You add 1, and you guys are pretty awesome at this step. So we should have all found that b is equal to a -1. Now, if we have the same slope and we have our b, we can now very easily write our equation. So our new equation is going to be y is equal to 1/2 x minus 1 for it to go through the point 4, -2 and be parallel. So that's how we do things that are parallel. It's a fairly easy process, similar to what we did in the previous lesson. Alright, let's see if we can try another one here, but this time we're talking about perpendicular. Remember that we said the perpendicular lines are going to intersect. They make a 90-degree angle, and the slopes have a special relationship. They are opposite reciprocals of each other. So if a slope of a line is 3, opposite of that and a reciprocal, so the opposite of 3 turns it into a -3, and then the reciprocal of it turns it into a -1/3. So the opposite reciprocal is the relationship to the slope that we have when we're dealing with perpendicular. So that is super important that we all know that slope changes to the opposite reciprocal with perpendicular lines. So example number 2. We're going to need more space than what's provided for us, so here we go. Again, we've been given an x and a y. We need to turn this into slope-intercept form so that we can make it have very easily for us to find what our slope is. So if I have a 7x minus 2y equals 3, I'm going to then make it solve for y, so I'm going to subtract 7x from both sides. So I'm left with a -2y is equal to a -7x plus 3. Next step would be to divide both sides by a -2. And when that happens, we're left with y is equal to a 7/2x minus, let me subtract that out of there, get a little quick eraser. We're going to subtract because 3 divided by -2 is a -3/2. Now, my slope here is the only thing that I really care about, and that was to find this information. So now that we know that m equals 7/2, I'm going to use that and have the opposite reciprocal to use for my new m. So my new m is going to be a -2/7, and that's the one that I want to use. And then I also have my x of 4 and my y of -1. So I use all the numbers that are in the box to create my new equation. So just like we did on the previous problem. All right, so y is -1. My slope is a -2/7 times x, which was 4, plus b. And we're just going back to doing math. 2/7 times 4/1 gives me 8/7. So I have an 8/7, which is negative, plus a b equals to a -1. To get this by itself, we're going to have to add 8/7 to both sides, plus 8/7. Now, if 8/7 is 1 1/7, and I'm going to combine that together with a -1. So I have a 1 1/7 plus a -1, makes my 1's go away. So 1/7 is the only thing that's left over. That's going to be equal to my b. So I have my information. I'm going to highlight it in yellow for us. This is the important stuff to now create my new equation as you're following along with your work. So my slope was a -2/7, so I have y equals a -2/7 x plus my y-intercept, which is 1/7. Now those are not very nice numbers, but it is a line that is perpendicular to the graph of this 2x plus minus 2y equals 3, and it goes through the point of 4, -1. So that's the way math works. One more time here. Our job is to describe or determine if any of these equations have a relationship that is parallel or perpendicular to each other. So step number 1, put them into slope-intercept form. We're going to sift them, and then we're going to look at the slopes. Step 2, look at slopes. All right, so this guy, to make it into slope-intercept form, we have to subtract 3 from both sides. So we have a y is equal to a -3x plus 12. This one's already in slope-intercept form. And then to make this guy, we have to do a little bit of work. 2x minus 6y equals -5. We're going to subtract 2x from both sides to get the y's by themselves. And then we have -6y equals to a -2x minus 5. And our next step would be to divide everything by a -6. We're left with y is equal to a 1/3 x plus 5/6. So let's go back to that same color. We have our new one, 1/3 x plus 5/6. So if we look at these two, I'm going to make color combinations here. These two are parallel. One too many L's. This one is perpendicular to each other, along with this one and this one are perpendicular to each other because opposite reciprocals. Okay? So that is how we determine if they are parallel or perpendicular. Everything has to be in slope-intercept form for us to check these slopes very, very quickly and easily. That's what you guys got to do for your assignment. Here's what your assignment